Good morning, sir. This is Group 32. These are our members, and today we would like to present our smart ramen kiosk system. My name is Ng Han, and I would like to talk about the background. So, what is a smart kiosk? It is a type of digital board that may be deployed in public locations to give the users a variety of services and information. Another one is it is also considered as an important component of smart city efforts that use data and technology to tackle the urban problems, such as the sensor and IoT devices is used to gather data about the city services, assets, and resources, and also use the analytics to turn that data into insights. The next is what service or functions can be provided by the smart kiosk. So the first is it allows the user to have a quick access to the information. Next is it will provide the way of finding, which helps the user to navigate the route and destination. Besides, it can also enhance the efficiency of transportation, such as looking for the transportation schedule. In addition, it can also support online transactions as well, such as buying the transportation ticket. In late 1970, the people would buy millions of PCs and hundreds of PC off-shelf devices in 1990. There was a company called International Business Machine Corporation, as known as IBM, was involved in the development of enhancement of the several technologies. This is a summary table of smart kiosk history. You may feel free to have a pause and take a read. Now I would like to talk about the future trend. In the future, smart kiosks are expected to integrate more futuristic technologies as well as bring more affordable to the users. Also, smart kiosks are expected to develop better hardware at lower cost. In conclusion, advancements in the smart kiosk technology is a double-win situation for both business owners and the customers. As for business perspective, it can maintain operation for long hours without the need of human staff. And as the customer perspective, the data gathered from their interaction with the smart kiosk can improve the service, the product, and customer experience. Hence, it is only a matter of time before all types of industries will using smart kiosks in some way. That's all for my part. Thank you.
Hi, my name is DJ Wei. I will be presenting about problem statement and the objective of the project. So, it has been a chaotic situation ever since the COVID-19 pandemic. The truth of what we are facing right now is the negative impact brought by the pandemic, especially for the food industry. Traditional business model of a restaurant includes many human interactions, which is highly not encouraged within these crisis circumstances. Therefore, modification of the business model is necessary. Yet, digitalization of a business model may be costly. Not to say that unique features need to be included in order to run a competitive business. Our project objectives, in short, has 6 in total. They are to develop a personalization solution on given data using Amazon Personalizer, to visualize the data using AWS Quicksite and allow the concerned parties to make decisions based on the visualizations, to store data items in DynamoDB for visualization, to provide a serverless solution on food ordering and rating of dishes, to develop an user authentication solution for management of registered customers to the kiosk system, and lastly, to develop an IoT solution to monitor temperature of external environment and detect customers that show symptoms of sickness. That's all for my part. I will pass to my next teammate.
Now for a comparison between cloud service providers. As you can see, AWS, Azure, and Google Cloud all have their own variants of different cloud services, such as computing, blob storage, schemaless database, IoT systems, data analytics, intelligence tools, as well as AI-powered recommendation systems. Each of them have their own pros and cons. For more details, you can refer to our report.
Good day, my name is Athena, and I will be presenting on the architecture diagram of our proposed system. The system can be divided into 5 main modules. The first module will be the user authentication module. The customer user is able to authenticate themselves with Amazon Cognito by accessing the API gateway endpoint. Next, the serverless order, getting menu, and rating function module. Lambda function event will be triggered based on the function performed. it will then be stored in DynamoDB. The third module is an IoT solution to monitor external temperature. The IoT data is collected via IoT Core from the sensor and passed it through AWS Lambda to be stored in DynamoDB. The fourth module is the user personalization module. Amazon CloudWatch will trigger an event to take a snapshot of DynamoDB to S3 bucket based on the schedule. It will then be passed through AWS Personalize to generate recommendation of items that are personalized based on user ID. The final module will be data visualization, which is carried out by Amazon Athena and Amazon Quicksite. Athena will be utilized as a query engine for the database, while Quicksite works as a toolkit to visualize the query data. All the relations in the database can be seen and selected to be visualized in the dashboard for further analysis. This is the demonstration of the user authentication module. Firstly, we create a user pool under AWS Cognito. We will allow users to sign in with their email address. For simplicity of the demonstration, the policies are set to a low level of security. The password strength is set up as such, and we will allow users to sign themselves up. Then we turn off multi-factor authentication, set email as the attribute for verification. We then create an app client to obtain the app client ID. In app client settings, we check on the Cognito user rule and define address for the callback URL and sign out URL. Under allow authentication flow, we check the option of authorization program. Under allow authentication scopes, we check on email and OpenID. In the domain name section, we define a domain name to set up the user interface for authentication. Note that there are some users that had already been registered in the user pool. With a Python installed and some HTML file, we can invoke a HTTP server that utilizes this authentication. As this project does not focus on web page design, plain web pages are used in the demonstration. After typing in the user credential, it is seen that it has successfully logged in. Next, this is the demonstration for the serverless function for ordering item, rating, and getting menu. First, under Amazon API Gateway, three functions are set up respectively with their own methods, which are get menu, order item, and rate item. The help function is just to test the connection of the gateway. After that, the API is deployed with a stage name, which will invoke a URL endpoint. The Lambda function for each method is defined in AWS Lambda. This can be tested by using Postman application. The getMenu function will return the food item that have been stored in DynamoDB. The order function allows user to order item based on the food item exists and the record is stored in DynamoDB. The rate function allows users to rate each dishes after eating their meal and store the record in DynamoDB.
Now I would like to perform on the AWS IoT Code. First, we need to go to the Manage sections and click on the things. We need to create a things in order to get the 4 keys, which will then be transferred into the virtual environment Raspberry Pi. These 4 are the keys that can be downloaded once the creating is done. This is the virtual machine of the Raspberry Pi, and these 4 are the keys that had been transferred into the Raspberry Pi. This is the Python code. So these 3 are the file location of the transferred key in Raspberry Pi, and these are the function code of the thermostat. Before running the Python file, we need to open the SenseHead emulator in order to get the input. So the emulator is open already, and let's run the code. We can see that the connection to AWS is good, and here is the temperature captured. and the user may get different results once the temperature is increased or decreased. So this is the latest temperature capture, which is 2.4. Once the temperature captured successfully, we will then need to transfer the message from the Raspberry Pi into the AWS console. So we need to go to the test and click into the MQTT test client. We need to subscribe a topic name, which is this: electronic innovation. So we already subscribed the topic name, and we need to open this console and run again the Python file. So here are the 3 temperature successfully captured from the emulator, and we can see that in the MQTT test client, we successfully passed the message from the Raspberry Pi into the AWS console. So the next step is to store the message into the DynamoDB. Go to the DynamoDB services and go to create the table, which is this. In order to store the result from the MQTT test client into the DynamoDB, we need to set the rules and policy to the database creator. So after the rules and the policy is done, then the result will then be stored into the database. This is the result, which is the latest one, 2.4 Celsius.
So for Personalize, first we'll have to export the order data from the DynamoDB to the S3 bucket in CSV format, which is the format specified by Amazon Personalize. So here is our test event. You can see there's the table name, the S3 bucket name, the folder we'll put it in, and also the file name we'll be using. Now if we refresh this, it will be added. Next, at Amazon Personalize, we will need to create a dataset group. For this project, we will just use custom. So just continue to fill in, and this is the schema we are using. After the dataset group is created, we will need to use an import job to import the data from the S3 bucket to Amazon Personalize. Here we already have a dataset group that we are using, manual Personalize, and we have actually already imported a dummy dataset which consists of 1000 different entries with at least 2 items tied to each user, which is the minimum requirement specified by Amazon Personalize. After the dataset has been imported, we will need to create a solution. Now that the solution has been created, we can create the solution version. After the solution version has finished creating, we can then use this ID to create the campaign. This one. We'll update this and run it. Now that the campaign has been created, we can get the results. So for example, this would be our test event, which will look for user ID number 1 to get 10 results. We run it. So here it is, the 10 results returned. To have this run on a schedule, we'll be using CloudWatch Event Bridge. So create a new rule. So for example, to have it run daily, we'll be using this cron expression, which will have it run every midnight.
Hi, I'm going to demonstrate about Athena and Quicksite. Before we configure Athena, we need to be aware of 3 things. First, we need to make sure that the Athena query engine is version 2. Second, we need to create a S3 bucket or so-called spill bucket for Athena to store its temporary data. Third, we need to know our data source. In our case, we are using DynamoDB. Therefore, we need a lambda function, which works as a connector to let Athena access the table of the database via SQL. Now, we can play around with the Athena with SQL to query with data. Good thing about Athena is we can save the useful query so that we don't need to retype it every time. For example, we can get the menu list by one click. The result will be shown right here. That's it for the Athena. Now, let's move to the Quicksite. Quicksite is a business intelligence tool which helps in visualizing data. All we need to do is import the data, which is right here. For our case, will be Athena. Then we will choose the DynamoDB. Now we can choose either one to be visualized. Going back to the interface, this is the one I had created earlier, which is about the rating of the dishes. We can select the value of axis Y and X and also the visual type according to different data, which is very convenient for further analysis. That's all. Thank you.